The shaded region shown in figure 4 is bounded by the x-axis, the line with equation x equals 9, and the line with equation y equals 1/3 x. We can see all of that in the diagram. This shaded region is rotated through 360 degrees about the x-axis to form a solid of revolution. The solid of revolution is used to model a solid right circular cone of height 9 centimeters and base radius 3 centimeters. This point here would have coordinates 9, 3, because we can see that with the equation there, and it's also marked on the diagram just here. The cone is non-uniform, and the mass per unit volume of the cone at the point x, y, z is lambda x kilograms per cubic centimeter, where x is between 0 and 9, and lambda is a constant. And we need to deal with that non-uniformity when we do our integrals. Part A is find the distance of the center of mass of the cone from its vertex. So the first thing I want to deal with here is the mass. Now that is going to be pi times the integral from 0 to 9, so along the height, of lambda x 1/3 x squared dx. Now when we look at that, the pi and the 1/3 x squared dx is just the usual volume of revolution, just the pi y squared dx. The lambda x has to come in here because of the non-uniformity. We're just doing mass equals density times volume. So that is going to give us pi times the integral from 0 to 9 of lambda over 9 x cubed dx. So pulling out the constants, we've got lambda pi on 9, and then this will be x to the 4 over 4 from 0 to 9, which is lambda pi on 9, 9 to the 4 over 4, and you can cancel 9s or you can just sort it out on the calculator. It comes to 729 lambda pi on 4. Now, we need to use the fact that the moment of the sum is equal to the sum of the moments. Now the moment of the sum is going to be what we just worked out, 729 lambda pi on 4, and multiply that by the position of the center of mass. The sum of the moments is going to be pi times the integral from 0 to 9 of lambda x 1/3 x squared dx. Now this part here and the pi in front are just part of the standard integral where we do the integral of x y squared, and once again the lambda x in here is to deal with the non-uniformity. So that's going to be pi times the integral from 0 to 9 of lambda over 9 x to the 4 dx. Remember, that's all equal to 729 lambda pi on 4 x bar. So we've got lambdas that we can cancel here, like so. And we've also got a pi that we can cancel out. So we've got 729 x bar over 4 equals 1 over 9 x to the 5 over 5 from 0 to 9. Now you can use the calculator to sort some of this out. Remember that 729 is a 9 cubed. So we've got 9 cubed x bar over 4. Over here we've got 1/9 of 9 to the power 5 over 5. And so we can get rid of one of those and knock that down to there. 9 cubed will cancel with that, so we've just got a 9 over there. So we have that x bar over 4 is equal to 9 over 5, giving us that x bar is 36 over 5. A toy is made by joining the circular plane face of the cone to the circular plane face of a uniform solid hemisphere of radius 3 centimeters, so that the centers of the two plane surfaces coincide. So it's going to go on here basically. The weight of the cone is W newtons, and the weight of the hemisphere is kW. When the toy is placed on a smooth horizontal plane with any point of the curved surface of the hemisphere in contact with the plane, the toy will remain at rest. We want to find the value of K. So we just draw a diagram from the side of this situation. We have our cone, and then we have the hemisphere here. And what we're being told by this paragraph just here is that the center of mass of the whole thing must be here, just where they join. Now we've got a W acting this way from the cone and a KW acting this way from the hemisphere. We know the overall distance here is 9 for the cone and 3 for the hemisphere. We have this result here from the formula booklet, which tells us that this distance here would be 9 over 8. This distance here would be, using our result from earlier, 9 take away 36 on 5. So 9 take away 36 on 5, W, that's the moment for the cone, is equal to 9 kW on 8. That's the result for the hemisphere. So we get 9 over 5 W is equal to 9 kW on 8. And 9's cancel, W's cancel. So we get 1/5 is equal to K on 8, giving us that K would be 8/5.